And I'm like so high energy tonight. I'm not even gonna let that get me down. You see that 20 that I was showing you earlier? That's a real 20. I'm just gonna cut to that. That's a real 20. I rolled that for those of you who were here. That's real. I was like blowing up when I was talking to Jesse. I'm like, all right, hold on, let me just roll real quick for stream. 20! Yes! I'm totally excited. Sorry if I hurt your ears. There's like just gonna be some crazy stuff tonight. So what are we talking about? We are doing randomness. This is one of my favorite topics in computers in general. Randomness is wonderful. And
it's random.
It's random. Here we have Jesse on screen. And oh my goodness, Last Mile's rating with a party of 36.
Party time.
I am really glad we sorted the audio out before all you Raiders came. Hello, Raiders. Thank you, Last Miles. Last Miles, the first sub in this channel, a badass in his own right. How do we even do shout outs? Can we do shout outs? Is the bot there? Last Miles. I don't know. Is this... Yes. All right. Bot's even working. Okay. Let's just pick up the randomness. Let's just let the entropy like bubble up because we're going to need it for this stream. We have issues here with how do we make randomness when we're talking about a computer. I mean, everything is deterministic. So where are we going to harvest this wonderful randomness from? Because that doesn't come free. That really doesn't come free. So I'm throwing the glove on because I think it's time to talk. We are.
Let's do it. I will say entropy is one of my least favorite words because depending on what background you're from, it can mean a whole host of different things. So it's like, it's got so many different meanings at this point that without clarifying what field you're talking from, it's almost become meaningless, which is a certain kind of irony.
It has a definite meaning here. We're talking entropy in the heat death of the universe sense. Okay, so let me cut over to the whiteboard. So we're going to just find our whiteboard, which of course, oh, come on. You don't want to do that. You want to get the screen here. Why? Man, that's just, what a stream.
It's a good sign.
It's just going to be one of those nights. You know what? I don't even need the whiteboard. We're not even going to worry about the whiteboard. Like, we could have the whiteboard on the main screen. So we'll go with that because that whiteboard just wants to misbehave. So,
that works.
So can I do something? Can I just a self shout out? I am 6 people away from 6,000 followers.
That's awesome.
All right, if we got 6 people in here not following Last Miles, help us out. Help the wizard out. He has some awesome emotes that were drawn by chess grandmasters and other great stuff. So you can, I think we threw the shout out in here, so it's already in that channel. And if you can, if we got 6 there, then go grab it. I think the key to that, Last Miles, we're probably gonna have to plug it a little bit later when we get a few more people in here. So we will do that. We will re-shout you out because 6,000 followers, it seems like a really big deal. All right, so I'm sorry, it's not going to be heavy on the whiteboard because the whiteboard is just misbehaving tonight, but we can draw here because this is random, and so that's randomness. Okay, so we have 2 types of randomness. There's 2 major topics we're talking about, which is going to be PRNG and TRNG. All right, and the difference between these, aside from a single letter and a corny joke, is this is pseudo and this is true. And this RNG is random number generation. So we are going to concern ourselves first and foremost with pseudo-random number generation. And this is all about doing some math and looking random.
Approximating randomness.
And this is all about generally measuring something, measuring physical phenomena. So this is typically like, the famous example from Silicon Graphics, long live Silicon Graphics is dead, is the lava lamp. So this is the source of entropy that used to be, you could basically take a camera and like point it at this thing and say, all right, which way is the lava going to go? That's going to be random numbers. So this is a notion of like true random number generation. So this typically comes from some type of hardware. Not always, but sometimes it's like just misuse of hardware. Sometimes it could be like, a long time ago in something called Pretty Good Privacy. I know, I'm sorry, Last Miles. Rip Silicon Graphics. I miss Silicon Graphics. Hey, what's up? I'm Nom Nom. And
excellent name.
I'm not sure if Cloudflare is still using lava lamps, but we might actually have to build our own entropy source. I'm not sure. So this is our last topic in C as an additional language. This is the missing parts series, and for those of you who don't know, this is like the full syllabus here. We're here in topic 11. Topic 13, which is
lucky number 13.
Lucky number 13. This is basically it for the meat of the course. And the next session we're gonna kind of just wrap up and go over what we learned. And we'll have a freshly minted C programmer. So let's.
I don't know about that, but I will do my best.
Oh no, we'll join the ranks here. Let there be tornadoes. The last great SGI demo was that was in Twister. He had like a SGI laptop. All right, I'm totally get that. That's a discussion topic.
For the drinking portion.
That's the drinking portion later. So that's okay. Let's just Silicon Graphics pour one out for SGI. Okay, that's like a totally different mindset. Okay, Anyway, pseudo-random number generation. So true random number generation, usually you have to do something physical. You have to digitize it in some fashion. You might, like in PGP, it used to be done with inter-keystroke timing. So if you time to like the microsecond, like every keystroke, and you type a lot of keys, like the delta between keystrokes is kind of random. You can extract a couple bits of entropy from that. And here I'm hand waving entropy. Entropy here we're just taking as sort of like how random is something, like how not deterministic is it? So
okay.
Now that's so we don't really have to worry about that too much tonight because you're going to be coding up a pseudo-random number generator. All right, and how do we do that? Right. Typically, coding a pseudo-random number generator takes 2 phases. You usually at startup seed it. So this is going to be like the basis of whatever number sequence you're gonna work with. And typically seeding, this is going to be sort of deterministic after that. So if you use the same seed, you can get the same set of random numbers in the same order. And then you're going to have something which is actually like sampling it. And sampling it is really, typically this is like, give me a random number. And that is all about basically taking this seed and storing some internal state about like, what we were doing, what we've done so far, and doing something to it, and then popping out another random number. All right, so pretty good, right?
I think so.
All right, so in here, we just have to do some math.
Now that sounds a little hand wavy.
I'm gonna throw that in air quotes for you, just to extra hand wave it. But
God,
the sum math by the way, in your first version of a pseudo random number generator, the sum math is totally up to you. So you're gonna invent your own random number generator. Okay, I'm gonna give you a very famous one. Sum math is my favorite math. Sum math, best math. Okay.
Now it's like every paper I've read today. It's like, oh yeah, then some math.
All right, you start off with these initial conditions, and then some math, and then random numbers. Okay, so that's basically what you're gonna do. Now,
okay.
How do we we're going to talk a little bit more about what good and bad means, and that's going to be the quality segment. So I've got that kind of broken down as the third topic. But let's just say at a high level, just very quickly, what would be bad for random numbers? I mean, what do we want with random numbers like at a high level?
Randomness?
Yes, we want randomness, right? So...
Is this a trick question?
No, it's totally not. We just want some randomness. So that means that like predictable sequences, and easy to spot sequences, and things where I can easily go forwards and backwards. These are all bad, right? I mean, these would be like the description of like a terrible random number generator. Like if I could just look at whatever number and know what the next one is, then that's not very random. And if I can look at a given number and I can go backwards and say, I know what you had before, and I can attack your crypto keys and get in your base, then that would also be bad. So we'll talk a little bit more about that later. But I'm going to give you the Randall Munroe random number generator. I'm going to start you out just because I'm a helpful guy. I'm some coding guy. I'm some helpful coding guy tonight. Okay. So for those of you who are new raters, everybody else, this is the multi-user pad where both of us get to type, and mostly Jesse's going to be typing. So I'm going to type a little bit, just tiny little bit. So let's call this the paradigm. And of course, now for random numbers, I have to implement generally both of those things. So I need some sort of seed and some sort of like next random number. Okay, so for our purposes, we can usually refer to those as seed the random number, srand, and rand, get the next random number. And these happen to be the function names that are typically involved in C.
Okay.
This is in the stock library. So I'm going to call this one, just to get you going, the, let's go Randall Monroe. Is it M-U-N-M-O-N? M-U? I want to say that's terrible. Let's just find out. Actually, you know, I even have it right here. So I don't know if he has his name showing, but no, Randall. No. Ugh, embarrassing. Randall Monroe. Let's go with the U. First guess. It is a U. All right, sweet. All right, cool. That is a natural 20, I'm telling you. All right, Randall Monroe seed, and let's just pass in some sort of number seed. So we're gonna simplify tonight. So we're just gonna keep everything uint 64s. So we're just gonna assume normal size for 64-bit architecture. So and this will be the seed number, and we pass that in, and we're also gonna write and this will just pass back the Randall Monroe rand. So this would be the Randall Monroe srand, and this would be the Randall Monroe rand. Chat, don't spoil it. And this takes no parameters because I just want a random number back, right?
Okay. Okay, so the XKCD wasn't a joke.
No, it was chosen by fair die roll. So that's legit. Okay, that's. How do we know that this sucks? So despite the fact that this was randomly chosen, what properties does it have?
I mean, it's predictable,
easy, forward and backwards. It's basically it's the
time.
trifecta of bad, right?
So, badness.
Okay,
right.
Which is, now he's trolling, obviously, but so that would be the first one. I'm some helpful guy, so that's that.
Oh, wonderful! Thank you.
I'm gonna execute that for you. I'll just run it for you. We'll Randall Monroe srand this with 10. Just to be ornery, and we're not even tracking our internal state. We're just throwing it out. I mean, it's just terrible, right? So let's just say that uint64t first num is this thing, and let's just print it out. So look at that. This is all the coding you're going to get out of me tonight. So we're going to call this a UL, because it's a ULL. Is that a ULL or UL on this platform? I always forget. So that'll be the first num. Okay, we execute it, and no, it's an LU. Dyslexic moment. All right, so let's clear that. Let's get our specifiers right. Okay, there you go. The Randall Monroe number generator. That's your first one. Okay.
That is significantly less helpful than I thought. So.
Oh great. Man, that's a great suggestion from last Miles. I should really return a 20 because I rolled a 20. But anyway, so and then we'll say for some value of 20. All right. So I've mathed it up. So there's some math and it's right. Okay. So go ahead. Give it a go. Give me some random numbers.
Okay, all right. So, So is this one of those things where I should go off and do some coding and you talk to chat and then
No,
ready?
We don't need to get that.
You're gonna look over my shoulder.
All right. No, not that complicated. We're just. I'm not asking for like a particularly good one. Just let's start somewhere. So. And by the way, for your first random bespoke
Yes.
chunk random number generator, let's say that it's like die rolls and it's going to be a 6-sided die, or we could use a 20-sided die for last miles in reference to last miles comment. So let's say that it's numbers from 0 to 19.
Oh crap. Okay, I had something planned. All right.
Oh, did I ruin the
Okay.
plan? Do you really want a 6-sided die first? Because
No,
that's okay.
no. I was thinking of like.
I have one. We're good. If you need a D6.
No. You're totally fine. I was thinking of
We got D6s like all day. Like this is.
So I mean, if there's like, I will start out with bad. Okay, it will not be good, but I have a cool idea, but it would take a couple of minutes, and so let's just say that we have this seed. All right.
Look at all this D6 action we got going on over here. We even have like a proper.
And you said D6.
Yeah. Well, no, you're doing D20, right? I don't want to spoil this beautiful roll that I just did earlier, so we'll.
Okay, hold on.
No, Nathaniel Bumpo. We're not doing a Mercine Twister.
Okay, so
MacGyver's trolling a little bit too because we both love the Python, but we're doing C tonight, so. Ran chonk.
okay.
By the way, Nathaniel, we're going to give you better than a Mercine Twister tonight. I think Jesse's going to get there. I mean, so that's already random, right? If memory was initialized randomly.
Yeah.
Well, let's try that one out. What do you think of that?
Okay. So here I'm going to change this.
I got a little bit of a bit kappa. I got a bit kappa coming for you.
So there you go.
You're returning 10. It's pretty much always 10. Okay, so
so not random, not predictable, easy, or it is predictable, it's easy.
I'm gonna get rid of this Randall Monroe seed because
Okay.
I don't feel like that's helping you. And we're gonna just go ahead and look at that. What?
There we go.
What happened? What? They're different. All right, so actually, this is a pretty good random number generator, just for reference.
So
why does that work?
and you could write. So it's just it's the memory address of where chonk is, right? Or it's like whatever's in the memory that previously where it's initializing chonk.
So GCC has kind of a couple modes. One of them is you can say like pre-clear memory. You know, Linux has modes. It can say pre-clear memory that's being handed out for allocation. Depends on your memory allocator. We wrote chunk alloc. If you chonk alloc, then you get you actually zeroed it, I think, at first. But in this case, like you're just getting whatever happens to be around. I mean, that you don't know what's in that memory. I mean, maybe I'm revealing like my password and I don't even know. Let's get rid of that. Like maybe this is like revealing entropy here. So yeah, I mean, one other like fun little allocator we could do is we could like return an address. I mean, we could just say like let's give ourselves a pointer and just get that number. Is that crazy? I mean, like, because you don't know where this thing's going to land in memory, right?
Yeah.
So it's not terrible, but
well, I mean, because it raises the question though, how is it chosen? How is the next chunk of memory chosen when you initialize?
Case, you're sort of grabbing whatever happens to be sitting in memory. So you're using environmental randomness from the system, right? You're sort of harvesting a little bit of randomness from. Now you don't know what how the system's running. So like if the system is like acting in a very deterministic fashion, or if an attacker can make the system act in a deterministic fashion, this is a bad random number generator.
Okay.
But in this case that we just saw, it's not bad, you know. It's probably like Linux is probably handing out consecutive chunks of memory, so you know we probably want to randomize like how much memory we. Anyway, so moral of the story, like not terrible. All right, but let's get a little math in there. Let's actually initialize some variables.
What I had actually wanted to do, so let me think about this.
And by the way, Rand doesn't get to have its own seed. So if you want to seed something, you got to follow the POSIX convention and put it in a separate function.
Okay. So let me think about this.
I like that one. Last miles.
Because I was thinking about like, essentially, the way that I'm thinking about it is that if we are just trying to approximate randomness, then the more complicated a mathematical function, the harder it is to be predictable, or
it's probably harder to spot what the pattern is.
Yeah, exactly.
Yep.
And especially if you use like more like stepwise functions, or functions that have like conditional kinds of applications, then it would be.
So you do some bitwise stuff in there to kind of stir it up a little bit.
Yeah, I mean, because obviously that's going to come into it. But I'm trying to think about.
Yeah, so start off with what you were just saying. Those are some great ideas.
But you took away my seed.
You can store the seed. You can have the seed back. All you need to do is write a seed function.
But it doesn't return anything?
No, all it does is initialize internal state. That's the point of seeding.
Okay, so
here, I'll give you a little internal state. All right, so the simplest seed function would just be internal state gets seed.
Gets the seed. Okay.
Okay, so now you've got something to work with for internal state.
Okay. So let me think about this. Make some variables that I can mess around.
Oh, by the way, thanks for the follow, 9null9.
But
whoa, I missed a few follows. I'm sorry. Math Fisher, Music Links, Kernel Image. Wow.
So all right.
Wow. And a kingly gift of a tier 1 sub. Thank you, Last Miles. You got an emote. What? I get an emote. What?
What
does this mean? Hyper reveal. What?
Whoa.
Got some emotes tonight.
What's a hyper slam? What even is a hyper slam?
I don't know what that is. But that's awesome.
It's cool.
Sweet. That's random. So you could actually harvest like Twitch chat. That's a nice source of entropy.
Okay, yeah.
Let's not do network code. All right. So yeah, give me some pure math. I mean, start off with some simple math and we'll get better.
So I guess where I'm struggling is that like I want to be able to pass it a number, like a starting place.
No. The point of this function is so starting place, that's seed, right? I mean, that's done in a separate function. But the point of a random number generator is you ask for a random number, it gives it back to you. So there's no argument that you pass.
I know. I wanted to like.
Otherwise, that would be like do some math to this number.
I know. Okay. Like I just want to do math to the number.
Well, you could do math to internal state.
I guess that's true. Okay. So let's think about this.
Start to save new stuff. Happen for your account. Oh, cool, Last Miles. Thank you for the generous subs, and that's Yeah, I'm still kind of a Twitch noob, but what I can tell you for those new subscribers, you have some of the best programming emotes on Twitch from what I've seen of live coding. You have some wonderful stuff like this. This is not code that we're going to use to refer to Jesse right now. This is some code that I was looking at earlier today. I would describe it as a dumpster fire. And look at that pixel art.
I've waded through my fair share of dumpster fires. Let me tell you.
Yeah, we have some dumpster fires, and that's fine, right? This is fine. And also, don't use a regex. No regex parse. Okay, so
I really like the dog with the flame meme. That just makes me I have empathy, like a deep connection with that meme.
Oh yeah.
It just feels like life. So
yeah.
Okay. So what was I thinking about doing here? So
give us a little math.
Yeah, I'm working on it.
Math up some internal state.
I'm working on it. I'm trying to think of like something obnoxious here. All right, so I want to. So
I wouldn't go for super obnoxious because we got a lot of material to get through.
But I like being super obnoxious.
Okay.
Let's do this.
Oh, BSD daemon, that's awesome. I used FreeBSD for a long time. It speaks to me, last miles. I think that's why I made the jump to Gen 2 because, portage, that was the kind of Linux that I needed. That's great, last miles. I'm a big fan of FreeBSD. I think if it wasn't for Gen 2, I might not have come over to Linux. Yeah. There you go. Some things.
Okay, and then let's see. Then why not?
That sounds good.
There. I did random stuff.
All right, so start that. Hit it a few times.
No, because hold on. This can't get past anything now. And we also need to capacitor seed.
Yeah, usually you seed at like startup time and, random numbers happen wherever in your program.
So can I just kind of pass? It doesn't return anything, right? So can I just do like that and pass it something? Or is it going to poop on me?
No, you're good. Paul Blart just cracked me up right there. Okay, except
those are not the random numbers. Oh, because I have to change the this.
So it's only good as your seed. But let's not worry about seeding. Let's not worry about separate runs, right? Because those are always going to be the same based on your seed. We want the run to be deterministic. So if we give it a given seed, we always want it to kind of go through the same numbers. That's a good property so that we can reproduce things later if we want. But I mean, your pseudo random number generator is only as good as your seed. I mean, if your seed is well known and baked into the code, it's basically a garbage random number generator, no matter what math you do to it.
Fair enough.
But the issue that we're more worried about is what happens if we do this like 5 times. And, we take this and we do something like that. And then...
Well, if it has the same seed, then it's just going to be the same, right?
Yeah, which is not great for like a given execution, right? It's okay that like it always sort of starts off at the same place with the same seed, but it's not good that every time I go to your random number generator, I get back the same number. I mean, that's the same as returning 4, right?
Ooh, hang on. I've got an idea. Okay.
Last miles, absolutely. And don't tell her that. Beer from Austria, nice.
I want beer from Austria.
I want beer from Austria too.
So
Last miles is beer sniping us while we're trying to nerd snipe ourselves.
okay.
Orsetti, thank you for the follow. Appreciate it.
So
What's sort of the issue with calling ran chunk in this program?
well, so it's always going to yield the same number. So I was thinking about having some conditions in there.
Well, you don't need to have conditions in there because they're going to return the same thing because seed, your internal state's always the same.
Well, so
what's important every time we return a random number?
I mean, it should be different.
Uh-huh. So how do we get it to be different, keeping your same math?
I mean, and not changing the seed?
Well, seed only happens once at startup time.
Yeah.
But we can change internal state.
What do you mean?
What if I added a line to your program? Every time I run this, take internal state.
Oh, I see what you're saying.
And add 1 to it.
Yes, okay. I see what you're saying.
Okay, so if I run that, I'm starting to get some different numbers. Now, the issue here is these are still, they look like they're incrementing, they're monotonic,
Yeah.
There's sort of some badness happening in here. So I don't really want to add 1 to my internal state because that's going to make it kind of predictable. So what do I want to do to my internal state? The entropy term for this is I want to stir it.
Okay.
Randomness has such great language.
So obviously, like a more complicated operation than just adding.
Oh no, this line, yes, like line 17, sure.
Yeah, you want to do something more complicated.
This is sufficiently complicated. What you got on line 15.
But we want to do something complicated to internal state.
Yeah, we want to stir it a little bit.
Okay.
Sounds good to me.
I'm not done yet.
Okay.
Yeah.
Let's take a look.
Random operations. Whatever's in my brain. All right. Okay. I'm working on it.
Okay. What's our issue now?
Now it's just getting enormous.
Yeah, we're getting big stuff.
So let's.
Uh-huh.
Which would, okay, still getting.
But we're still doing that increasing.
So,
we are stirring though.
Yeah. Let's see here.
Let's stir it a little more.
So.
Whoa, what's good? Last miles, knock it off. You're killing me with your kindness here. Thank you so much. Appreciate it. Nathaniel gets some awesome emotes to use for programming humor and satire.
Let's see. First, let's see. Maybe I need to make. Okay, so that's okay. It goes back down.
Right.
It goes back down.
That's
so
good.
I'm actually gonna let's see if we can just
mess with a little bit. Okay.
Okay, so I'm thinking
sort of like season to taste, stir to taste.
By
the way, Loafbone, did I get NC's level right this time? I had to do a quick change. Is she a little bit low?
Still getting large.
seem like it. Okay. Raced a little bit.
I might have just started mumbling off though. So
No, that's okay. I just want
okay.
I bumped you up a little bit.
Ooh, wait. Oh no, that wouldn't work. Never mind. Nope. This is C land. Okay.
I mean, mod is a pretty good way to go.
Yeah. I like that. No, whoops. Oh, because
that's awesome, Last Miles. I appreciate sharing the love. Live coding.
Back to this.
So this turns out to be a little harder than we expected, huh?
I mean, so they're getting more random. It's just they're getting too large.
They are.
So
I
need to like.
You need to just keep on stirring and keep it. But I mean, here's the thing. I think you got the idea. I mean,
yes, I do.
Like this is pretty fair. Like maybe sometimes you want it to go up, sometimes you want it to go down. Maybe you use the last bit for that. I don't know. Who knows like how you want to stir this? But
ooh, I have an idea. Hold on. So, nope, I can't do it that way. I have to go. Well, poop. Never mind. No, I don't want to deal with that. I don't want to do that.
Like we know it's evenly distributed and bonk, if it's even, we go up, but if it's odd, we go down.
Yeah, you could put a bunch of like conditions in there.
Yeah, we could jazz it up all we want. I mean, you got plenty of operators to stir with. But I mean, the idea is that you're sort of like tuning it. You're looking at the output. You don't know what the seed is going to be ahead of time, right? So what we want is we want it to perform well no matter what the seed is that's given to it. All right, so it depends. You know, it's like one of those things. Like that seems to be behaving a little bit better with a larger seed. I mean, again, like, so this is like something, when we start testing our randomness, this is like some of the factors we're going to have to incorporate when we do our stuff. Okay, well, you feel pretty good about that, right?
Yes.
Okay, well, I am going to show you. Okay, so that seeding, what we could do to kind of analyze this is we could run a whole bunch of random numbers, like not 5, like 50, like 1,000, million. I mean, we could run a whole bunch of these and start looking at the distribution of them.
Yeah.
And if we sort of pull that together, like we should see kind of like an even distribution. We don't want to skew this. We want to see that it's like kind of, you know, stuff is getting spread around and it doesn't seem to be following any sort of patterns. A shortcut to do that is called a randograph. So basically it's the same idea as what I just said, but rather than bucketing it and putting it into a histogram, histograms are cool, but you know, sometimes histograms are not cool. Sometimes you're tired of looking at histograms. So maybe you want to look at it a little more graphically. Well, what you can do is you can choose 2 random numbers and you can use that as an X and a Y in a picture.
Okay.
And you can look at the pattern that emerges. Okay, well, that's a randograph. So we're not going to do picture generation tonight. I don't want you to code that much.
We have not done anything with visualizations yet at all.
That would be a little bit evil. But if we took a quick look at the PCG paper, which we're going to get to a little bit later, here's a nice little implementation. By the way, if you can see the screen, this is a really nice random number generator. And you'll notice it looks kind of like yours. You know, it's taking a big number, it's taking some state, it's adding some stuff, it's shifting some bits, it's XORing with something, it's shifting more bits, it's doing that, it's playing around. So basically it's like just a bunch of math.
A shift would have been a good idea.
Yeah, so shifts are cool.
I like that.
Shifting by a random amount is cool. Shifting the other way by a negative of that, you know. I mean, so like, you know, they've basically been stirring. And by the way, this is years of research. Like this did not just happen, right? This is.
Oh yeah, I got close.
So you were actually kind of getting the idea pretty fast in just a few minutes. But like, you know, when you start studying and you're looking at the distributions and you bring your data science mind to it, you'd spot like some of the problems with the.
My data science brain is out for lunch.
That's so totally fine.
Too much data science today.
There's a nice paper. Actually, we're gonna get to that later. We're gonna get to that later too. There's a nice paper, not from NIST, which of course I don't have handy here, but let me. I threw the link away, of course. But one of the things it does is sort of like tracks PCG and sort of like, which we're going to get to in a second. And it looks at like how distributed it is and like, how it deals with those various properties that I just said, and it makes some nice random graphs. So let me just look real fast if I got it. Here.
So I have read an absurd amount of papers today.
Oh, don't worry.
Interestingly,
I won't quote you on that.
I'm trying to think if like there was something with randomness, but that was so many hours ago that it's been overwritten. My brain is like some kind of I don't know.
That's totally
circular buffer. It just gets overwritten with stuff.
They have a paper. Let's see. Is this the paper? Yeah, this is totally the paper. Harvey Mudd. Cool. So if I'm just going to jump down a little bit, there you go. If you apply the technique that I just mentioned, this is how you get a randogram. So,
oh, cool.
I'm sorry for the people looking at this on stream because this is the worst case for video encoding. So it's literally the worst case for video encoding. It's totally random data. If you're interested, you can go take a look here at the link. But basically, this is sort of what you want to. You want to see the middle here, but you don't want to see the left, right? You see a lot of pattern here on the left. And again, this is generated exactly the way that I just described. It's like you pick a random number for the X, you pick a random number for the Y, and then you plot a point. So if you do that for all the different entropy sources, like you can see very quickly, like bad, good, totally random, right? So white noise would be awesome, right? But that gets a little bit into distribution, which is something we're going to talk about momentarily. So that's a randograph. So I can show, well, we already just saw like really briefly. I like that they put up on PCG, they put the they put the totally minimal, you don't want to download a thing implementation of the algorithm. And it's right here. And we can, because it's Apache license, we can actually use it. Thank you, Apache license. So it doesn't include the seeding. So basically we would just have to seed this ourselves. They have a nice, clever way of doing seeding, which is neat. But just looking at it, it kind of works the way that what you were doing, right? It takes some state, says, okay, this is where we started with our old state. Now we're going to take that, we're going to multiply by this ridiculous number, which is hopefully, I don't know, probably prime or some special property of this number. It doesn't really matter. It's just that it's big enough that it's going to cause overflow occasionally. So the number's going to wrap around and come back. And then it's also going to add in a little bit that it was storing in in the internal state. So then all we have to do, look at this, they even commented it with this implementation. This is crazy, right? You can then you can do this shift. We're going to calculate two parameters, this XOR shift, which is we're going to take the thing and we're going to shift it a bit and XOR it and shift it some more. And then we're going to do this rotation thing, which is we're going to shift it all the way down. So we're going to try to get a small number here, but still keep a little bit of whatever randomness we had before. And then we're going to apply the property all together, and that's the number that we're going to return. So we're going to take the XOR shifted, we're going to shift it by this small number of rotate. So we're not going to throw away too many bits. We're going to OR that with shifting the other thing, and then we're going to negate. We're going to take the inverse of the bits, and we're going to do a bitwise AND with 31, which is not quite 32. So it's going to just take the low part. That's another kind of shifty trick.
You told me there would be puns.
I told you there's going to be some puns. I had to get that going somewhere. So there's going to be a little shifty trick there, and then we're going to use that to shift this the other way, and we're going to OR them together, and that's a pretty decent random number, I think. So why don't we try?
I had a quick question. So
while you're questioning, I'm going to run this thing.
Okay. So like obviously there would be a lot of perhaps permissions or whatever issues that you would have to navigate for this. But if you could access like a some kind of like hardware property, like the
Oh.
temperature or
Oh.
something like
I
that.
love you brought that up because that's coming.
Because okay, all right, because then you're kind of,
This is why I said entropy in the heat death of the universe sense.
well, because I was thinking about like the only real entropy, right, is observable physical phenomenon. And so how can you do that? Well, observe some kind
Yeah,
of hardware
you need physical phenomena,
attribute, right? You
basically.
need
I
a
mean,
physical
and
phenomenon
that's
to
the dividing line between pseudo randomness and true randomness. But one of the nice things about pseudo randomness, if I know what it's seeded with, I can reproduce it.
yes.
So it's nice that it's deterministic. It's also
Hmm.
terrible that it's deterministic because that's sort of the
Depends on what you're
antithesis
using it
of,
for, right?
yeah.
So
So
yeah.
that's why we want these properties, but we accept up front that anything we do for pseudo randomness can't be truly random, like
Hmm.
just by nature. But if I take this seed and I just quickly stir it up, I'm just gonna give it some state. We'll just say that this is like 5, and I don't know this. What else does it need? It needs this ink. So we'll just say seed.ink is gonna. We'll just start it at. We'll start it at 1 just to be ornery, or 4 because we use the Randall Monroe. And we'll take that and we'll pass in seed. Then we should get back a number, which is another sort of UN64T. And this we'll call mystery because it's so random. Okay, and then we'll just print out the mystery is. And then this is going to be, what did we say it was? LU? I always mix it up. UL? LU.
It's yeah.
LU. All right.
LU.
Mystery. I'm glad compilers tell you nowadays. Okay. And this is going to be, this is yelling at me because it needs to be a pointer. So I'm going to remember to pass that in like so. And stuff happens. Okay. So I probably took down our execution environment, which is cool. So
Oh
yep.
boy.
Yeah,
Oh no.
I
All right.
think we did it. Yeah, that's just a little. Okay, no, it did come back. Okay, so no, this undeclared identify. What I mystery. Oh, because I commented out the seed. No, don't do that. Okay, so we'll run this, and I think the instance is still up. It is, but it's really struggling. So I must have done something that it's not happy about.
Oh, that's like story of my life. What did I do to it?
What happened to you? You could have been
Why
a contender.
are you being like this?
Okay.
Oh goodness.
Yeah. Steve, this guy is fun and funny, and Jesse's learning. Oh, I totally am missing stuff happening here. Oh, cannot allocate memory. Sweet. Okay, so
The chonk alloc, come on.
yeah,
Jeez.
we just ran out of memory. Nice. That's a solid win right there. So we're gonna just hand wave the rest of the PCG and say that it works when you don't break it. So I'm gonna kill that real fast, and that's gonna cause this thing to go crazy, and then I'm gonna bring that back real quick, which is like so. Okay, so multi-user pad back in operation. Let's not run this program as it stands. Okay, so I'm gonna just kick out the PCG. We're gonna save that for later. Okay. All right, so that's, by the way, as you can see when I get it right, in just a few lines of code, you can get some nice like stir. You can get some nice internal state management, and that's all pretty cool. One of the things that you was it your yeah I think there's a loop that's going on in there that was misbehaving. I'd have to analyze it later, Joel. I don't want to bore everyone with that. So what is 5e mode shared? What is going on? Oh, last miles, you're just
There's more gifts.
There's
Gifts are happening.
Oh,
there's just a shower of
look
gifts.
at that BSD devil that Swills has. That's awesome. Steve, the kicker of the hornet's nest. Jitter Entropy does this. Nice. Okay. Well, Sorry, I'm getting totally lost here. So let's, all right. So you feel pretty good about PRNG, right?
Yes.
All right. So, and it immediately brought you to a new thought. And I want to follow that thought for a little bit, because you were wondering about how do we get some sort of hardware stuff. Right. But before we get to that, what I am going to tell you is that, like I told you in the earlier example, starting off with sort of PGP, and they were looking at like interkey timings. That meant that like back in the day when you were generating a PGP key, it used to say like, okay, bang on the keyboard a lot. Like,
okay.
And you would sort of like, it'd be like, how much entropy have you collected? Like, you know, no, you don't have enough bits for a key that big. So you'd just be sitting there like, and then eventually they added mouse inputs. You're like, I'm trying to get enough. You know, it was just kind of insanity. So like at some point, some clever OS dude, I'm not sure if it happened on FreeBSD first. I feel like it might have. I don't remember. But somebody came along and said, you know what's really good at doing all this is let's let the system do that. Just sort of like always collect this sort of like background free entropy, you know, so like stuff like, for example, banging on keyboards, moving mice, things like that. And generally looking at any interrupt. You know, so they would even look at clocks, like and say like, okay, the real-time clock, and have the processor clock measure, and the processor clock's very accurate. The real-time clock is, as NTP referred to it, a time of day device. It's time of year.
The funny thing is, like, when I was thinking about that
time
thought,
of year device.
I wasn't thinking about like keyboards or mice or anything. I was thinking about telescopes, actually. And so how the quote unquote random interference created just by the CCD and the electronics that are working causes a kind of it's random-ish, but it's a kind of noise that you have to filter out when you're analyzing astronomical data. And so I was trying to think of like,
as an astrophysicist, you're perfectly suited to think about natural sources of entropy.
For randomness, right?
Like all that stuff that you're filtering out, like you don't filter that out. You save that. That's artisanal randomness. That is like 100% all natural,
bespoke,
homegrown
organic,
randomness, organic, free range randomness. You take that from the environment. You keep it. You know, you stir your internal pool, and you just sort of keep that around. So that don't throw that out. That don't.
I'll send you my dome flats next time.
I know you spend all this time pulling this noise out, but that's the good stuff, right? You know, you gotta keep that. Okay. So I know sometimes you want to like actually like do some science, and that's fine too, you know, but like, you know, sometimes like keep that stuff. But, yes, totally. So yeah, I actually started building a website where I was thinking of like a long-term troll on stream was I was going to sell free range randomness. And then I was like, you know what, like figure out how to stream first and like come back to that later. So I actually have gotten as far as setting up like a Squarespace, like selling, and I had my first sale, and it was a pain in the ass because I actually had to like report taxes for their sales tax in Connecticut. So I actually had to like.
I do not miss.
I had to file I was like, oh my god, I don't want to sell randomness anymore. Like just filling out the taxes for it. But anyway, so we're gonna get into the black market randomness on this stream. So, all right,
I can hook you up.
So, that's and. Really fast, we're going to just borrow a modern version of that because we're running on a Linux container here. So we can actually pull that. There's a very well-known device because like I told you on Unix, everything's a file. So there's a well-known file you can open up and it's called dev-random. And it's not so cool as sibling, I don't know, urandom, which is and these two are like sort of related. Sometimes they're actually implemented the same. It depends on the system, you know, the version and choices that people make. But yeah, hey kid, I love Steve going on. Hey kid, want to buy some random numbers? I got any one of those coats. I got some.
I just was typing that as like that, like creepy trench coat, like with all the watches. Like,
it's totally awesome.
But it's randomness.
Anyway, this dev random file is sweet. It's binary. You can open it up and you can just pull some randomness out of it. Don't starve the system. So please just read just a little bit of randomness. But do you remember how to read on a binary file? So we did this a little while ago.
Oh God. maybe.
Okay.
Oh God, it's been a while. Okay, hold on. Uh, let's see. So like, right. Hold on. Actually, how much of this can I remove?
I mean, it's just how much do you want to save? I mean, I'm fine with you removing all of it if you want.
Okay, yeah, I got
We've
you.
done
Okay.
our pseudo-random, so we're getting
So,
we're moving domains here. And yeah, last miles, I do think that it originally did start with FreeBSD. Maybe Steve or one of you guys could comment on that. I feel like I saw that on FreeBSD. It's just been a while, so I don't remember. But I do feel like that random. Oh, and thank you ASDF Monkey for the follow. I appreciate that. Oh, and Steve for the follow. I missed that as well. And Perel Cobra and Fizzbly Twitch. What's going on here tonight? This is so crazy. See, you roll a natural 20. Last miles feels like rating. Magic happens. That's old BSD. Okay, yeah, I do feel like that started on BSD. I feel like Linux picked it up and said, hey, that's a pretty good idea.
crap. What was it? It was like something dev something. Like
Yep, dev random.
God.
Don't slash that. It's a real file.
Yeah, sorry. That was an accident. And then we want to read it, and it's binary.
That is
right?
correct. I'm gonna give you a bye. You don't have to worry about return types. You just assume that everything works.
Yeah. I wasn't gonna because I do remember us going.
I'm
over
gonna
that,
give you one minor change. I'm gonna open urandom, and the only reason I am is because the difference between the two is random kind of guarantees that you're gonna get true randomness, well, as good randomness as it has. Urandom says just feed you randomness, so like it never runs out, even if the quality of the randomness drops. So we don't want it to block for stream, so we'll use urandom instead of random.
So here I think we need, hold on.
No, last miles, we're not checking return sheet.
I've done that before. So we need a buffer, right? To read some of this stuff into?
Yep, except you can actually just use an int, because if you just read an int worth of it, or a uint 64 worth of it, that's fine.
I'm trying to remember how to do that. Hold on. I know it's fread. I'm trying to remember. It's like,
first time
I think Linux, the middle thing is the size. So.
Oh, thanks, Steve.
Oh. It's just 8.
Interesting.
And then the file. I remember that. What is
FreeBSD 2.2 was like my first FreeBSD. I still have the CD somewhere. I have to go dig it out. I used to hang it in my cube at when I was at Netflix, and there's a lot of FreeBSD people at Netflix, so they'd be like, "Cool."
Oh wait, is that just? I think this is the thing that I got to put it in, right? It's a buffer.
I'll give you the man page.
Sorry, it's been a while.
No. I don't
trying to remember.
You don't need to remember anything that you can find in the manual. That's okay. So that's it.
Thank you. All right, so it's the size. Okay, that's fine. And then number of members. Okay, and then the file. All right.
Don't use language like that in here, last miles. We don't want to talk about SCO and what happened with the SCO period, the shakedown from the SCO organization. Sadness came to Santa Cruz. that's totally SCO. Paul is so it became they bought a lot of the rights. The original some bad stuff happened with Unix. It's a long story. There was, for a long time, you couldn't use the word Unix, and then there was like kind of this shakedown from SCO trying to demand, like, they're like, we're going to get you later if you don't pay us some licensing fees for that Unix you got over there in Linux. Yeah, it was a dark time for Unix, but BSD and Linux eventually sort of plotted a course towards free, and the rest of us were allowed to use Unix without paying crazy fees. I'm grossly oversimplifying the Unix wars, but that's just a dark topic. The bad old days. But 4.4 Tahoe, can I get an F in the chat for that? Come on, I mean I'm gonna throw that down myself. The 4.4 Tahoe release was awesome.
I have no idea what I'm doing. I don't remember this. I'm sorry. I'm like trying
totally
to piece
fine.
this together. Like,
Thank you. Thank you for
it's
the
been a
notes.
long time. I think that's okay. I think that's fine.
Bad stuff happened. Open Solaris. F. No regex. Nice CCB.
Where is this?
C's the best.
Oh, it's like that.
Linus didn't make Linux. That's a great handle. It was made by the community. Come on. Okay, so that's not a big deal. L
N. Oh, oops. Okay, whatever. Now it's pooping itself.
Okay, so
I didn't think I did it right. I can't really remember.
Hold on. Buffer is an array here.
Yeah.
Right? So you don't necessarily need to read it. You only want one, right?
I guess so. Yeah, I grabbed extra in case you wanted me to go through and grab more.
Let's make it so that this thing crashes if we, sort of hope it crashes. So we're going to take thing and we're going to turn it into a pointer.
Yeah. Okay.
And size of thing, that's cool. That's the size of one of them. And the neat thing about using the variable name is that, if you change the type later, this code will still work.
Yep.
You're going to read one of them from the file handle. And then you're going to dump out, not buffer, we're going to dump out thing. So
yes.
Let's go, and this is another one of those. L, and I'm going to do that again. So if we get that right, cool, we get a number. So actually you're basically on, right? So all I did was I just switched away from using the buffer. Now we used the buffer in previous cases because we were mostly working with 8-bit data. So your notes are going to mislead you here. But
okay.
But basically we can read from this thing, and we're getting some nice random source, and that's basically the kernel sort of like collecting entropy on our behalf and saying, all right, I'm going to stir the internal pool and here's some stuff. And it works pretty well, and it can combine different sources. The modern version of that is pretty long, and this is the piece of the Linux kernel that generates the dev random device. This is an example here. So you've learned enough C that you can read this now. So the one additional thing that they're sort of doing is, they're gonna okay, so there's trace point here, so you don't have to worry about that. They're gonna cha-cha a little bit, which is a variant of salsa. So this is about
I can do both.
Yeah, they do not want to return the internal state directly, because that would let you if you knew what the function was, that would let you guess future values. So instead, they're going to take the thing and they're going to hash it. And we covered hashing in 2 topics ago. So
yes,
it turns out cha-cha is a pretty nice hash. So they're going to use that to sort of hide the internal state, and they're just going to let some numbers through. Okay, so that's the gist of that. It's going to pull out some random numberness, and it's going to mem copy it into wherever you passed in. And then we're going to make sure that you can't go backwards and protect ourselves, so that we don't want to be able to look forwards or backwards. And we're going to zero that out just to make sure that anybody who's being naughty is going to get some zeros. So that's actually, this is from the dev random implementation in the Linux kernel. And you have learned enough C to start reading the kernel. This is a big deal. There's more comment in this file than like code. You'll see a call out here to pretty good privacy. That's PGP, Phil Karn. This is a long story. We'll get into that some other time. But there is a ton of stuff in here that you can read about stirring pools and entropy and all sorts of other fun stuff. So I'm using the version on GitHub just because it colors it nicely for display. So
it's pretty is basically what you're saying.
It's pretty. So
it's okay. You can say it's okay.
All right.
Yeah.
Now we saw PCG. So we've seen what a high quality pseudo-random number generator. We've seen one that collects stuff about the environmental noise. That's cool. So that gets us to the second part, which is really true randomness. So that's enough of that pseudo-randomness, right? We're done with that. Like, junk randomness. We want lava lamps, okay? We want like that thing to be like a lava lamp with a blob, and where is this thing moving next? Okay, so that's
truly stochastic number generator.
Yes, truly a stochastic process of some sort. So we're talking about PRNG, and
if you just drop the R, I keep thinking of Star Trek every time you write that.
So I can TN. Oh, I'm going to get into a license no, I didn't write it. I didn't write it, Gene Roddenberry. I'm sorry. Okay, so anyway, moving on. TRNG. So what do we do with TRNG? Well, the idea is we take it from the environment. So capture something physical. And that's our most common way of doing that. So we have some sort of physical process going on, which is represented by this box, which I'm just going to call physical process. And it could be a lava lamp. It could be stardust getting formed. It could be, is there stardust getting formed? Is that, I can't even talk like that.
It's okay.
So it could be things that last miles can link you
reference.
About. That's you could be astronomical in where you're gonna. I'm gonna pun the hell out of this. Okay, so we take some sort of physical process.
I just thought lava, star, astro. Like people joining in are like, what?
Stardust. Okay. So we're gonna take some sort of capture device, and I'm gonna turn sideways to write this. So we're gonna do some sort of capture. This is some sort of ADC type process. This is an analog digital conversion of some sort. So we're going to capture that in some ADC process, and we're going to spit out some bits. And this is going to be, we don't have to worry about revealing internal state unless the physical process has some sort of, repetition to it, which would be really odd for just about any physical process. But we could take that and we could cha-cha with it, or, whatever we want to do if we want to hide some more details of the internal state, but not really that important. So I'm going to leave that alone. We're going to take these bits and we're going to feed that back. Well, it turns out Intel got clever a little while ago, and they said, you know what? We're going to add that to every Intel processor. We're going to make an instruction just for you.
Oh.
And that instruction is the RD-RAND instruction. It was introduced a little while ago. It's basically available in just about every sort of modern Intel processor you would see. A binary star was born. Nice.
Oh, that's just like, if people are interested in how stars form, Dennis clipped that from my channel. I'm just explaining how stars form. So, yes.
By the way, for those of you who don't know, the Enceladus is an astrophysicist. Part-time C coder by night, but you can check her out.
Data scientist by day.
Data scientist by day. So let's throw in Enceladus.
I've not been streaming as much letely. I need to. I'm sorry. I'm sorry, dear friends.
I can't even spell.
I have too many jobs right now.
Let's just throw that in there and say that that's a shout out. Okay, cool. So.
Close enough.
I have a nice.
Yeah, you got it. No,
works. I have a genitive problem there because your Enceladus is. So we're gonna need advanced use of the apostrophe in the next version of this blog. Okay. So anyway, you can check out her stream, and she can tell you nice physical processes that you can capture that we might do some bits. And actually, we should do a little bit gathering someday. Grab a little stardust, grab a little astro. I don't know. That might be fun.
That could be fun. Yeah.
So we'll do some entropy harvesting. So for tonight, we're going to assume that this wonderful instruction that Intel wrote is totally fine.
I'm guessing that's quite an assumption.
It's so totally fine that I am going to use this wonderful emote that was written in pixel format.
Oh no, I know which one you're using. Yep, okay.
This is fine. What could possibly go wrong with Intel creating a random number based on a physical process in code that we can't see at all because it's totally non-inspectable. It happens on the chip die. We have no idea. And this is the same company, by the way, that there was a release that they had a hidden processor and everything, and the NSA is watching all of your computer stuff and everything else that's going on. So guess how many people in the world actually use this instruction on a daily basis?
Like no one?
Absolutely no one, because we can't trust it. It runs fast as heck.
You should give it like a sketchy fedora.
probably is based on, I don't want to pick on the Red Hat people, but that's
fair enough.
Let's leave that alone for now. But let's just say that let's pretend for the moment that it truly is random, and it truly has no hidden supervisor sub CPU that could probably screw with it. But anyway, and by the way, Intel did try to push a bunch of kernel developers to adopt this, and there was trivial attacks shown that if that instruction happened not to be truly random, how screwed the whole world would be. But
oh god, okay.
Anyway,
well,
that happened. So what we're going to do is, because this is your last C class, I feel like we're just done with C. I mean, you know what randomness is? You have a hardware instruction that you don't have any access to. We're going to go, it's time for assembly. We're going assembly.
No! I'm not
done.
ready.
No, we're done. Okay, like we are going to go to assembly tonight, because I think you've seen enough of this boring C like that, because we're basically done with the language. You got all the missing parts. So we're going to have to say, I want a random number. Just like you had. Like, we're going to go chonk, or we're going to go bonk, or we're going to, I don't know, we're going to bonk this one. So we're going to take this thing, and we're going to say that, by the way, I don't want the optimizer to do anything naughty to this. So we're going to try to get this right.
I'm so sorry. 1 second. Hubble is screaming about something. So 1 second. I'm sorry.
Randomness. No, that's randomness. That's
dogs.
Great.
You want a random number generator? Have dogs.
You removed ME in your X230 replacing with core boot. Screw NSA. Nice CCVE. Some coding guy. What about recursive Fibonacci or linked lists and red black trees? And yeah, so you're that I view all of that stuff as the next course. I see that as the data structures and getting into algorithms course last miles. So Jesse is totally interested in continuing. I think that we're just basically kind of done with C as an additional language. At this point, she's been through all the basics of the language. We didn't do anything with the preprocessor, but I feel like that's not really basic C to begin with. So yeah, that's the nice puppo. Wife's okay. So why not? Oh, I'm sorry, Steve. I missed. Yeah, why not? That's probably in reference to the assembly. Instruction is crap. I knew it was going to be something crazy when I started mentioning the RD rand instruction. What do you consider a basic C knowledge? What I consider basic C knowledge, Linus didn't invent all of Linux, is right here. I can actually tell you my entire answer to that question. This is what I consider basic C knowledge. So I'm going to just link this real fast in the chat. This is my syllabus of free course. I'm giving all this stuff away of what I consider basic C knowledge. I don't actually cover absolutely everything. Like I don't mention enum other than in passing. I don't mention some of the bitwise like structs and some of the more like obtuse parts of the C standards. But I think that this is like pretty representative of like the kind of C that you're mostly be doing. Why not was in reference to I don't want to pick on the Red Hat people. Yeah, I feel like they get beaten up too much, Steve. I know some people. I mean, then they had those layoffs, and then IBM acquired. What was like? I guess Last Miles could probably talk about that a little bit more. Oh, and by the way, Radek Hanilika, thank you for the follow. Appreciate it. Yeah. So by the way, I'm stirring some entropy over here. We're gonna. You're back, so
I am. I had to. There was possibly a cat, possibly just a person, possibly nothing.
Who knows?
Yeah, so, it's random.
So this is one of those things. Like, so the way this is hard to read in the GCC manual, which I had to look at like 5 times before we came on here. So this, you always know you got the GCC tab because it's got this crazy pink icon, fave icon. So basically, when you're doing assembly and you want it to properly interface with C code. The hard part is how do you get stuff in and out of assembly because you don't know where the compiler is going to put things in registers and you don't know if the optimizer is going to change it. So anyway, there is a defined way to sort of interoperate with C if you're inlining the assembly. I prefer to not put the assembly in the C, but anyway, we're going assembly because we're basically there. So the way this works is we put the assembly in here, and then we say that this gets, and then we have to pass. Now this, by the way, you'll notice this is a directive. So this is not part of the C language. So I'm cheating a little bit here. And then we have to specify the output and the input. So this is what we're going to take, like variables in C. We're going to like bring them in or take them back out. So this is sort of mapping between C and assembly land. And then if we're going to clobber anything. And that's important because C doesn't know once you give me assembly, I can do anything to this machine. I mean, this is like we can run any sorts of instructions we want. So this, by the way, you're not going to have to worry too much about writing inline assembly, but it just so happens that this RD-rand is not that easy to grab. So what we're going to do is we're going to use this weird syntax to say that I'm going to use the same variable for input and output, which is this A. Normally it'd be an R for output. And then you just have to say what variable you want to use. So in this case, we're using bonk. So we're taking bonk and we're going to use it for output. We're also going to use it for input. So their way of doing that is you have to do this. And that basically says I'm going to also use that same variable for output. So when I see this variable, GCC is going to map it to a register, and that's getting into some stuff that we'll do in an upper level course. And we have nothing to clobber. So we're not clobbering any other registers because it turns out your first assembly instruction, the RD-rand instruction, only takes one parameter. Where do you want to store the result?
Okay, which is bonk.
Which is basically bonk. But the problem is to pass bonk in or out, I have to use these things down here. So that's why this is basically, I need to specify that this was the first variable that I sent in. Okay. So let's take a look at it. And then if we get all of that right, which who knows, that maybe that's the true randomness. The true randomness.
Oh gosh.
With assembly is I'm gonna be declarative. I'm like, this is definitely gonna work. And
gotta have faith.
We're gonna have faith. We're gonna spit that thing out as as a number.
Come on, where's your thank you? You always give me crap about that. So
thank you. Thank you.
Where's your new line?
Where's the new line? I totally yep. I deserve that. Okay, so we write that. Oh, look at that.
It's a number.
Look at this. It's the true hardware assembly environmental noise coming off the CPU, although this is a virtual CPU, so it's actually a lie. But anyway, like coming off the hardware is this thing. Oh my God. All right. I feel like that's going to be true enough until we get to lava lamps. RD-rand is a lie. RD-rand is a lie, by the way. So this is the cake is a lie. RD-rand may or may not be a lie, but none of us can observe its true state. So that actually is it for TRNG and PRNG. So that's all we're going to talk about for pseudo and true. Hooking up a actual ADC would be something kind of fun. We got a board here. We could totally do that, but I feel I've got
stuff here actually, so
I feel like
we could do it on both ends.
Like that's a whole stream in and of itself. That's a project stream. So like we'll save that for project. I don't think it's part of the lesson. And you even saw how to inline assembly. I told you in the last lesson I would start showing you the dark side. This is the dark side. Okay, this is where it's the
gateway language. C is the gateway language to assembly. Harder languages.
Once you've seen the ASM directive, you can't unsee it. That's it. Okay, so there's a few other things I have. We did talk about randograms.
Yes.
The last part of this is really just to say that there's this notion of quality of randomness, and we talked a little bit about that in the beginning when we said we don't want it to be predictable. So we don't want you to be able to guess what's coming next. We don't want it to be backtrackable. So if you see what it is right now, like say I have a cryptographic key, I can't guess things that were previously generated from that. So that has a lot to do with hiding the internal state from the environment. And it turns out there's a branch of government that does this for us. So they actually define standards which say whether the randomness is good. Now they don't really say if the randomness is good or bad. What they do say is whether it's bad. they really only define, like they don't say that something's good. They just say like, no, that's bad, right? So don't do that. I'm not saying if that's good or not, but don't do that. So the branch of government is NIST. National Institute of Science Technology, I think.
Of standards and technology, isn't it?
Okay.
Yeah.
Yep, that sounds.
I think so.
Here it is. Here's NIST. This is random bit generation. These are the actual specs. So you can see this here. Pseudo-random spec is this one. This is, they call it pseudo-random deterministic random number generation. Using an entropy source, this is about like hardware, so this is pulling it in. So recommendations there, and general stuff for when you're constructing this up. And they have some conformance testing. You can say something is FIPS standard 140 part whatever. So that we're not going to go through that because it's like one of those like massive, like you're going to read this like all day. And
I have been through way too many NIST standards.
There's specs like
oh yeah.
Like it's just that's just to say that doesn't say it's good. That just says it's not bad. That's all it does. Okay. So with that said, there is one quick implementation that tries to do some of this in an automated fashion for you. It is called Rng Test. It is built into most distributions. You can pull it from RNG tools. I think RNGD is the one who wrote it, which is the random number generator daemon. This was kind of before all this stuff lived in a kernel, and sometimes you had to deal with it. So there are some tools available online that will help you. And I like this example if you've ever seen random.org.
I have not.
It's a website dedicated to giving you random numbers. They don't sell them. I'm going to sell them because these are not artisanal. They're not free range.
Alas.
This is just not my kind of randomness. But they do claim that everything here... Oh, this fell. So they do claim that this is all true number generation randomness. And here's the results of various tests. Like, are all the bits evenly distributed? Blocks, runs. Are there runs of bits that look suspect? That kind of stuff. Okay, so any questions?
No.
Okay, well,
I don't think so.
With that said, and boy, we had a lot of randomness tonight.
We did.
I think we're closing that. We're closing all the things. We had our minimal PCG. We had the Linux kernel, which you looked at for the first time, maybe? I don't know.
Oh.
Your C is up to that point. This is actually the larger version of the PCG. And you can read, they have a great paper on it just talking about it, randomness in general. XKCD is just required reading. You have to be, if anybody ever asks you to implement a random number generator on a whiteboard, that's your go-to right there.
The level of sass. I love it.
Just no one should be implementing a random number generator in a whiteboard interview. But if they do, you can always stir some numbers and do some stuff if you want. But like, don't fall for it. Okay, like you should never be using a random number generator that's implemented on whiteboard in a coding interview.